So, good evening everyone. I hope you're still awake and you have still some energy left for this presentation. So I'm Blaise Jacholkowski and I'm an engineer by training from a Political School of Lausanne in Switzerland. I also have an executive MBA degree from Hult Business School in London, so I have both business and engineering backgrounds. And the past, let's say, 7 years, I worked in digital health. So I'm going to talk about that. Actually, I worked in startups. I was a co-founder. I was a CEO of another startup. And I also worked the past 4 years for an engineering firm, and we're building products for a range of customers. So be it startups, corporates, hospitals, medical device companies, pharma companies in the field of digital health, and especially regulated products, so aka medical devices. So that's my expertise. So my talk will be about digital biomarkers. So you heard already a lot about digital biomarkers today. So I guess you know more or less already what it is about. So I really believe that digital biomarkers are really a key component of digital health. Well, when you talk about digital health, you need to collect data. So basically, any markers which is collected digitally is a digital biomarker. But I'll come back to the definition in a second, and I'll mention how it is transforming healthcare today with this real-time data. So definition. So digital biomarkers are objective. They are quantifiable, physiological, and behavioral data that are collected and measured by digital devices. And I'm going to give a few examples of digital devices a bit later on. So they offer real-time insights, contrary to biological biomarkers where you take blood or you take your saliva and you have a snapshot of your situation at a given point in time. So here you have a continuous monitoring outside clinical setting. Sorry for this little view on myself. I don't know why it does this, because you miss a few words now here. And it's the first time I see that, but it's because I'm recording, I guess. So unless traditional biomarkers, as I said, they provide longitudinal high-frequency data which reveal some health patterns. So very important. So how digital biomarkers are collected? So you know all the wearable devices, and I don't need to explain to you, smartwatches, fitness trackers, so monitor heart rate and physical activity and sleep. You have, of course, your smartphones as well. They contain a lot of sensors. They contain gyroscopes and accelerometers and other things. And actually, today you can even measure your blood pressure through your phone. There's a company called Biospectral. You put your finger on the camera and you hold it, I think, for 30 seconds, and you can have your blood pressure measured now with that. It's being actually cleared by the FDA, and I think it's going to be launched in Europe pretty soon. It will be considered as a medical device. So you can track behavior, also location, usage pattern, which is quite important. For example, for mental health, tracking screen time or the behavior, how you interact with your phone reveals a lot of things about your anxiety levels or stress levels, for example. Then you have plenty of other sensors and IoT devices that are tailor-made for specific use cases and applications. So they capture biomarkers in your own environment, and this is the beauty of it. You don't need, you can go anywhere and it will track your, collect your data. And it's very important to collect data in your environment, because if you want to collect blood pressure at the doctor's office, it's going to be quite different, because there's what we call the white coat syndrome. When you go to the doctor, many people are stressed and their blood pressure goes up. So then their blood pressure is higher than if they would measure it at home. So it's good to measure it in a good environment so as to have any significant measurements and draw some conclusions. And then you have these digital health platforms. Some are regulated, some are not, which aggregate all of this data. And we need actually quality platforms to analyze these trends, visualize health metrics for being usable by clinicians in particular. And here I highlighted also a big difference between medical grade and consumer grade devices. So you have to pay attention to that, because a consumer grade device is usually not so much validated. It doesn't have to be developed under a quality management system, whereas a medical grade system device needs ISO 13485 certified QMS, quality management system, and therefore it requires 3 times more. You need 3 times more time to develop a medical grade device versus a consumer grade device, and it costs at least 5 times more. But you also have clinical evidence. So for consumer grade, you don't need any clinical trial, but for medical grade device, you would need a clinical trial to prove how your device is working and that is meeting the performance criteria and the safety criteria that you promise. So some examples of digital biomarkers. So you have, of course, HRV, as you may all know, very important to monitor your recovery, for example, after sport. It analyzes also your stress levels and cardiovascular health in general. Activity levels, I think we almost all of us count our steps every day. It monitors, measures the daily movement to assess your fitness and metabolic health. Sleep patterns, almost all of us also, I believe, track sleep nowadays, so I don't need to explain that. Gait analysis, so I'm going to come back to that. That gait means it's related to the way you walk, basically. So it's a good indication of your mobility and a good proxy for also mental health. And it can also explain some neurological issues. So if you have Parkinson's disease or multiple sclerosis, for example, your gait will be quite deeply affected, and you'll see that. And I have an example coming up just after. And voice patterns, actually we don't think so much about the voice, but there are a lot of voice biomarkers now which are being more and more used in also the clinical setting to detect signs of depression, for example. During COVID time, they developed also a system to detect with cough if you had COVID or not. And many other respiratory diseases could be actually identified through the sound of your voice or the sounds you make while you sleep, if you snore or not, and how you breathe during your sleep. So you have devices which track this as well, and it's quite powerful actually. So here I wanted just to show some examples of heart rates recorded on the Apple Watch using this app called Cardiogram. And it's quite interesting to see, for example, in terms of sleep, if you have restful sleep versus sleep after alcohol. So when you see that, I think you won't want to drink alcohol before going to bed anymore, because it's pretty clear that your sleep is very much disrupted when you drink. And if you wear a tracker, you probably saw that as well. And that's very visual. So it triggers action when you see these kind of things, because you see, wow, okay, right, if I drink before sleep, I will have these huge peaks of pulse for no reason during the night, and I will not feel rested. Also, you see emotions, so driving in rush hour. Well, I don't know if you are all at that stress when you drive, but I immediately notice also that I have a peak of stress as soon as I go in a car and start driving. So if you're in rush hour for long hours, that will drain you, and you can see that definitely in your heart rate. And you can see here a Microsoft interview. So any interviews, you may have peaks of stress when you're more quiet in between the sessions, and then you have another interview and you have another peak. So you can read a lot of things actually in these kind of diagrams. And of course, in the medical space, also you can detect some pretty serious diseases such as atrial fibrillation, which is a kind of cardiac arrhythmia. And actually Apple Watch is medical grade for this indication. So if you have an Apple Watch, and you might want to use that feature to detect if you have this condition or not. Here I wanted to present you something maybe you're not so familiar with. It's a kind of biomarker which is not so common, because this company called Magnes, actually you don't see the logo because of my picture there, they developed a shoe, a smart shoe called Nushu, and it's a health wearable that monitors and improves mobility. So you have a sensor, a gait analysis sensor in the shoe, and also a vibro-tactile feedback in the shoe. So it has an AI engine also, which analyzes through an algorithm the gait events. So it analyzes different things like, well, you don't see here a dashboard, but it's called stride velocity, stride length, so the angle, how you put your foot on the floor, etc. So there's a lot of parameters which are measured like that, and it provides feedback, which means it can correct and it can provide a little impulse which allows you to suddenly reverse somehow the downside of a neurological disease. So this shoe is actually medical grade. It was developed for people who have typically Parkinson's disease or multiple sclerosis. And when the shoe vibrates, it allows the people to start walking correctly again, because the Parkinson's disease in the late stage is not able to walk so much anymore, or really with a lot of difficulty. But just giving a little vibration at the right frequency at the right moment allows the person to walk almost normally. So I don't have a video, unfortunately, to share with you here, but you can maybe find this on the internet, and it's really impressive how it restores mobility to these people. And you have a companion app, of course, where you can check your progress there. So it's very interesting for neurologists who, and there's a lot of clinics now who bought this shoe. You can buy it actually yourself also online. It's also B2C, so for 1,200 euros, you can buy these shoes. But you probably don't need it if you don't have a condition, but it can also help you improve or detect potentially your issues with walking. And this data can be shared with a healthcare practitioner, which is very convenient because it's data you collect at home. You walk, you do normal activities of life, and then you go to the doctor and you show your data and you can have a diagnosis. So you have a lot of diseases which can be detected using digital biomarkers. I just mentioned a few right now, so I'm not going to walk you through all of that, but mentioned Parkinson, for example, heart disease, mental health disorders, and even diabetes. Now you have some devices which are still under development. It's been a long time that they've been trying to develop some like smartwatches or the likes to detect or to monitor blood glucose. And it's not yet on the market, but many startups are working on it, and they are pretty close, I think, of putting that on the market anytime soon. And it will allow you to monitor also on the go your diabetes potentially, or to track if you improve or not with your diabetes. So how do you optimize health span and extend lifespan with digital biomarkers? So obviously through this preventative approach, which allows you to optimize your lifestyle. So you have to be very proactive. So if you collect this data continuously, you can check these age-related changes. So you can detect cognitive, cardiovascular, metabolic health changes that support these interventions. It's really what we call a data-driven longevity approach, which can lead to new protocols. So they guide you into personalized strategy, and this is what is cool about these digital biomarkers, is that everyone will have different reaction to different food or different activities and so on, and you can really have a personalization of, for example, your supplements based on some of these biomarkers. And also the community and support networks. So you can easily share this data via platforms such as Strava or others more dedicated to longevity, which can help you actually as a consumer or patient exchange within these digital communities and foster this motivation and long-term adherence. Because a big problem today when you want to change is to adhere to a new habit, to build a new habit and to adhere to new practices so as to transform and become a better version of yourself. So last slide, the future of digital biomarkers. So I think we are really revolutionizing the tech industry through this innovation, and this is what we call medicine 3.0. So this is really medicine which is more precise, more personalized, and more predictive potentially. So thanks to AI and machine learning, we will have more deeper insights. We'll be able to really predict, because not so many of these devices today, if any, really helps you predict what's going to happen in the near term or short or long term, and provide also better recommendations. But to have recommendations, normally it has to be medical grade. If you're consumer grade, you cannot really make direct recommendations, or it has to be very nuanced. It cannot be really a medical diagnosis, for example. Integration into clinical practice. So hopefully in the future, doctors will start reading the dashboards and really better adopting also these biomarkers. So there's a lot of education still to do, so as for the doctors to learn how to interpret this data and also use it when they make their anamnesis and their diagnosis. When you see them, they usually they're not so knowledgeable about this. And last but not least, privacy and ethical considerations. So, of course, there's a big emphasis on securing the data, making sure it stays private and so on, so it has to comply with GDPR, etc. And this will be very critical because we will collect more and more data. Actually, a device can generate up to 1 gigabyte of data per day, and it might reveal a lot of things about your health condition. So you should be also careful how you share it, and that's why you need to have in place systems which ensure security and privacy. All right, so I think it's already time to conclude. So thank you very much for listening to me. If you want to connect, you can scan my QR code and it will connect on LinkedIn. I just put a little Swiss flag here because I'm based in Switzerland, so as you know. And you can also send me an email on my email address. Thank you again.
Thank you, Blaise. I will start from not usurping the mic. I will start from your questions, and then I will usurp the mic. Alona?
Thank you, very interesting. My question is, how many digital biomarkers approved, kind of, or like DGAS, or approved by FDI, digital therapeutics? I guess this is where digital biomarkers reside and live. What is the current state of the market, if you can say a few words, like approved digital biomarkers?
So you should specify what is approved, because DGAS, so just to explain, are digital therapeutics, and they are fulfilling certain criteria to be reimbursed by the German healthcare system. And they need to be medical grade applications, indeed, and some of them, almost all of them probably collect some kind of digital biomarkers. But I don't know how many of them, because digital biomarkers is a component of a solution, but the solution has to have a certain indication, and some solutions monitor, for example, it's for headache management, for example. So I don't know which biomarker is used for headache management. So
okay, let me try to rephrase. Everyone is walking 10,000 steps, I guess, in this room. This is kind of digital biomarker which is not approved, but we use it. What would be the next one, you think, big digital biomarker? Thank you.
Which will be approved from a regulatory standpoint, or which will be looked at? Because
looked at, thanks.
Because, I mean, you have dozens. So I think the most important today is probably HRV, heart rate variability, but it's already been there for some time. Pulse rate is a very common one. Body temperature also says quite a lot of things. Also for the fertility tracking. Fertility trackers are usually based on body temperature, mostly. And there's an algorithm which corrects for the right kind of measurement, because temperature is not so straightforward to measure. But then you have, as I said, a lot of new ones coming in terms of mobility, so measuring your movement, so exactly how you move your body and how you manage your steps. So it's difficult to say how many biomarkers in total there are, but you can think of hundreds of biomarkers potentially.
Thank you.
Joe?
Thanks. You made a distinction between medical grade and consumer grade. Do you see or think there's going to be some sort of solution to be able to use consumer grade data to translate that into sort of medical grade, so you don't have to always develop medical grade solutions from scratch?
Yeah, that's a very good question, and I think consumer grade data is problematic because a lot of it is very unreliable or not very accurate or not very precise. Accuracy and precision are two different things, and it's only when you have validation that you can really use for diagnosis or treatment. So consumer grade data you can use to train some algorithms, but you don't know what will be the quality of output, because if the quality of the input is poor, and because they're not obliged to go through this rigorous process beforehand, it's only measured usually afterwards by some YouTubers, for example, if it's a good device or not in terms of sleep tracking. There are some channels like Quantified Scientists where they look at that. But if it's consumer grade, normally the clinicians will have problems trusting it for good reasons and for using it for medical purposes. So hopefully there will be more and more medical grade devices. Actually, some companies such as With Things in France, they develop medical grade consumer devices. So they sell it B2C, but it's developed as a medical device. So hopefully there will be more of that, but as I said, it costs so much more money, at least 5 times more money than a consumer grade device.